Hello, everyone, and welcome to the March Systems Facing Call. Today, for our topic, we'll be discussing AI support. So we have all seen increased machine learning and artificial intelligence jobs running on our clusters. It's clear now how it's not clear how other institutions are dealing with the influx. Slurm configuration changes, partition names, common questions, performance tips, and community changes are all going to be covered in this discussion. So for this discussion, I'd like to welcome some facilitators for this. Jason Wells, Research Computing Architect and Data Management Lead from Harvard. Lucas Nogueira, AI and Machine Learning Analyst from Calcul, Quebec and McGill University. And Rob Naccarato, Director of Scientific Computing at the Vector Institute. I'll hand it over to Jason, who will start us off. Jason?
Thank you very much. I'm fighting to share a screen here. Somewhere. Sorry, there's too many screens here. I think I want that one. All right, can everyone see the nice parking lot?
Yep.
Great. So Jason Wells, I work at Harvard University School of Engineering and Applied Sciences, and I just wanted to share some thoughts on what I've seen over the past 3 years. When I got here back in 2011, I was aghast. We had our little school of 200 odd PIs actually had 7 GPU partitions and 11 compute partitions. It was really difficult to figure out any patterns of what was going on, and this is a necessary backstory to what we're going to reveal about the GPU problems. But there was a constant influx of people complaining about partitions being down all the time, lack of funds for hardware, ex-researchers using all the nodes, et cetera. And so I told the CIO that we needed to actually just move to seize compute and seize GPU and be done with this. And one PI said, no, I don't like that idea. But the rest of them all bought for it, and all the complaints evaporated. But pretty quickly, we had this problem crop up where we realized that no future jobs were taking up all the A100 GPUs, and the people that actually needed A100s were complaining about that. And so we had to take a step back and say, okay, well, how can we try and fix this? Things are getting fragmented, and SkedgeMD, thankfully, we had a contract with them, and they came up and said, you need to use Slurm weights to fix this. I will be providing these slides publicly just so people can get an idea, but I want to make sure people understand this at the very least. This idea that you can use these weights to essentially set the A100 nodes to be really quote unquote expensive, and then the no feature jobs will matriculate to those as needed essentially. And a good idea of this is the mask that they asked me to use. They set a suffix and a prefix in order to avoid some different issues that can happen. So there's a 1 on each end, but then they're grading the number of GPUs, grading the amount of memory, grading the amount of cores, and grading the generation of the CPU. And so the result of that is you'll get a score like 142171. Clearly, if you had zeros through all of these, or a 3 there, it would be the lowest score. And so the oldest nodes get this lowest score, whereas the best nodes, the 16 GPUs with all this memory and all this stuff, get the best scores. The jobs go to the lowest score first, unless you've clearly requested something, one of these special technologies or the specific number of GPUs. And that helped differentiate the jobs that actually didn't care what resources they were getting from the ones that did care what they wanted. And so that cleared up a lot of the problems that we were having. So then we started seeing more complicated stuff as we were able to dig into things. A common AI development workflow, for those of you who haven't done it, usually we're working off of a web page. And as you're going through that web page, you're installing packages and you're running code and again, and you're making little changes to it. The problem is all of this code takes a long time to run usually when you're importing data sets and then having to train it and do all this types of thing. And so you end up running it a bunch of times because, wow, this is actually working. What's going on? It's very much different from a fire and forget type of job where you're typing something up in Vi or Nano or Emacs or whatever, and then doing an S batch. And so oftentimes they even want GUI support so that to facilitate this workflow. And what we ended up seeing was that greater than 50% of our A100 nodes were being taken up by these campers, these people that just they were doing 7-day jobs where they would be on for maybe a couple hours per week. but they had requested a reservation for this entire time, and they were all interactive reservations. So we were able to solve that by gating the GPU partition with Lua scripts to less than 2 cores and less than 6 hours for interactive jobs. And I was stunned. I thought I was going to have a lot of people complaining, but in fact, it was really popular. Everyone was getting fed up with not being able to get GPUs, and when they suddenly could get GPUs, they realized that they could get their work done, and so it really forced researchers to learn how to use SBatch for their jobs, and that stopped the camping behavior that we were seeing. However, I created my own problem. 4 months later, many researchers are now launching hundreds of 168-hour one GPU jobs for neural net development. It's common to see 70%, 75% of my jobs on the C's GPU partition are AI and ML jobs, which is just based off the job and script names. So I'm entertaining all kinds of ideas. Some of the complications that we're seeing right now is just that people aren't realizing that new isn't always the best thing out there. Our HPC partitions are heterogeneous. We're seeing that in 2024, you can have V100s, A40s, A100s, and H100s all within the same cluster. And in fact, the B100 came out, and I haven't even updated it for this yet. But we'll actually sit at 64% utilization with jobs waiting because everyone wants just these two. And I see this constantly. It's always 64% with a big long list of jobs waiting. There's another 36% that are unused and will never be used because no one wants to wait for non-A100s right now. We don't have the H100s in the cluster. So one of the things that I run around telling people is this idea of time to science. We actually want people to understand that we've got this calculation where it's wait time plus run time. And if you're in a hurry, it can actually be faster to use the older GPUs. You will see this when the GPU partition gets really bad with all these people doing neural net development and training things and whatnot. Will it get up to 94% utilization because people start recognizing this and using the other GPUs? But it's a cluster architect's nightmare. I'm buying H100s right now. It turns out they're already outdated. The B100s are coming out, and I've still got RTX 2080s in my cluster. So I'm considering splitting the partition into GPU-based names as a result. That way people can sit there and run commands to see that the H100 and the partition is being completely used, whereas the A100s aren't using it at all. And hopefully then people will be able to matriculate towards the A100s more easily than they can now, where everything is one big partition. The other things that I think might be a little bit different is like data set issues. This is true story. I had somebody pop into our office hours and say, I'm trying to get Hugging Faces Llama code working with PyTorch on Colab through VS Code. And we had to try and parse all of those different things and understand what they were and be able to help that person. The other thing that's happening is this LLM dataset storage. I'll show you in the next slide what that looks like, but everyone is downloading these huge data sets, and oftentimes they're the same data set. And so I created this common data set storage area so that people could just start importing for their language models from the same raw data sets. That way we wouldn't be duplicating and using up all of our storage. We also get a lot of odd, like highly technical questions. Can we use MIG for GPUs? What's the amount of memory in the GPUs? What model are you using? They want specific documentation. It also comes down to the drivers that we're using, and then there's programming questions about Torch usually, where we're talking about the compute capabilities of the GPUs that we've got. And I really want to warn people about PyTorch. I've been bitten by it in the past where it'll suddenly drop support for K40s and you're stuck with a bunch of K40s and it's no longer useful. And so you have to go out and compile an older version of PyTorch where the support actually existed. And then complaints about capacity issues where there's not enough GPUs, or my favorite, which I ran into last week, oh, I had no idea the cluster was limited. They thought it was infinite and they could submit thousands of jobs and it wouldn't cause any problems for anybody. So the common LLM data store that I've got right now, these are all public data sets that you can go out and try and get. Archive, COVID-19, that's a medical database, and run emails. I hemmed and hawed about including that one because I'm not sure if we want to teach bad behavior to large language models, but it was there. MD-Wiki is a lot of medical data. Project Gutenberg is a ton of books going way back. Stack Exchange, of course, is a lot of useful information. And then Wikimedia actually has Wikipedia and a lot of other wiki-based data sets that are out there. Documentation, just ideas for people, partition information, program documentation, Slurm information, tips and trips. And then I was surprised to discover that a lot of labs out there have their own notes on how to use their cluster, the partitions and whatnot to avoid complicating things with other labs. Profiling is becoming critical. I was showing these slides to somebody and they told me I should go to the next slide first. So profiling is when you run a program through a function of some kind that's going to study the program as it's running. And so in this example, we're seeing that we're spending a lot of time notifying the user about what's going on, all those little print statements saying, hey, I'm at this point in the code. And it actually is spending a lot of time at that could be spent doing the rest of the code. And so we want to think about getting rid of the notify section there as much as possible. There's other optimizations that can be made. And so that a short thing like that can actually turn things from a month-long code to a week-long code. And then as a result, people are getting very interested in these types of profilers that are out there. And so I'll name a couple there. CUDA, we want to try NCU. Python, it's just called Profiler, but Numba, there's a Profilia, and there's many more out there. And as I mentioned, there's options and capabilities out there to greatly increase the efficiency of people's code, and that should be done particularly when you've got jobs that are waiting for weeks at this point. We do have an evolving landscape. The B100s were just announced. Grace Hopper H200 nodes are arriving, and they're almost immediately outdated because the B100s are announced, and we'll start seeing those in a while. The top 500 are being built with AMD's MI300X GPUs, which I haven't had a chance to get my hands on yet. CUDA cores and TPUs are differentiating. Now, people are asking for L40s and other types of GPUs because they've got better TPU cores, and that's what they're interested in. And then Cerebus is still out there doing their big chip thing. And so we don't really know, what's going on or where things are heading. So we actually started a research and development effort. We're going to try and get a little bit of these, one of each of these cards and try and run some benchmarking on them and be able to approach things and understand what's going on. So the latest developments that we've got, it's weird managing this cluster. The tragedy of common social element is real. That there's researchers emailing other researchers saying, hey, you're running hundreds of jobs. Do you know what you're doing? Could you please knock it off and maybe only run 50 at a time or something along those lines? I also get PIs asking, is researcher X, do they realize that they're using millions of dollars of hardware that I bought? And so it's getting a little snippy at this point, and we're having to really focus on user training at this point, reminding people that there's other people who use the cluster and that it's not infinite. So to wrap up, this is just the timeline of what I did. January 2023, we had that combination of PI partitions to the single and GPU ones. We implemented node weights in March. November, implemented that 2-core 6-hour policy. In the near future, I will almost certainly be doing GPU-based, like C's GPU, H100, C's GPU, A100 models in the GPU partitions. I had considered doing large and small GPU partitions. The idea there being that there's people who want to run 7-day-long jobs and people who need to get a result within 4 hours. And the other one is the time limits and named in the partition name. So it could just be a partition with a 3-hour time limit versus one that has 7 days. And then in the far future, TPU and CUDA partitions. I'm not sure if those are going to differentiate. I'm not, but we'll find out. So that is it for my section of this discussion. I hope I've introduced some things for people to consider, and I'll release it back to the moderator.
We do have one question in the chat for you. I lost it. Brian asked, have you thought about Slurm QoS limits like group jobs accrue or max jobs accrue to help with users that flood the jobs or flood too many jobs at once?
We looked at QoS and I don't remember why the Slurm admin poo-pooed the idea, but it was something about applying to all of the partitions on the cluster, and I've got 2 or 3 partitions based off of hundreds of them. So I'm not too sure why we didn't go with that option, but it's out there.
I was sort of curious how you set up the limits with Lua scripts. I don't know if you have time to talk about that now, but would you be willing to share that information?
If I can send them out to the list, I will. I didn't do that actual work, but I'll see if we can get a hold of those scripts and do that.
We've had similar issues that you talk about as well. We are using QoS for some limits. What I think our biggest problem right now is keeping up on the software. Because it changes so quickly, everyone wants the latest version of PyTorch, the latest TensorFlow. Are you guys experiencing that problem? And if so, how are you handling that?
I haven't seen it as much. It's engineering schools are really weird. People just manage everything on their own. So to half the time people are compiling code on their own and just kind of bypassing the problems that they get. It only crops up occasionally that we'll see people complaining about that. With profiling DCGM, I haven't seen that specific one. It's a lot of the labs are using NCU right now, which surprised me. I'm unsure as to why that one's so popular, but it seems to be in vogue, I guess. What else do we have?
Is there a reason to break out queues by GPU model versus GRUZ resource?
In particular, the reason I'm thinking about GPU model is because it's not there's two issues. There's one where people aren't realizing that the A100 or the older GPUs are out there, and I want to surface that a little bit more closely. I want people to see that these things are completely unutilized. The A40s, no one's using them. V100s, no one's using them. Oh, I just want the A100s and that's it. I think when we get past that, we'll get to the point where we're looking at the problem of people who want to do a week versus 4 hours. And I'm not too sure how we're going to get past that just yet. But other than setting a lower time limit priority partition or something of that nature. 2-hour runtime limits? Wow. Training models usually takes a very long time, so I'd be surprised if that worked, but that's interesting.
That was me that wrote the comment.
Yeah, Tim.
So those were for interactive jobs, so you could run up to 2 hours on them. And if you need another job, you could restart it. And so if you wanted something a little longer, you could pick a particular GPU. But if you wanted something now, you could hit that quote unquote GPU partition, which contained all the sub partitions, and pull up a job anywhere that something was idle.
Perfect.
It often didn't include maybe some very large investor partitions. Sometimes it did, sometimes it doesn't. Most of my experience is on CPU, so I'm kind of translating it to the GPU aspect.
John, checkpointing for GPUs isn't a terribly developed technology, so if you know anything, please do share. DMTCP didn't know a ton about it, and CRIU that seemed to only work for administrators. I couldn't really get it working for users.
You can do it in the domain pretty easily. You don't want to checkpoint the job from a Slurm or a machine perspective.
Right. What technology, though, for GPUs?
Usually in PyTorch and the other ones, there's just a save the weights function, and it'll save all the weights for you. And that's a very small value compared to dumping all the memory.
That's pretty cool. Okay.
That is something that users from experience, this is completely anecdotal here, but they're not used to doing. So checkpointing is not a habit, and it should be.
And that's the kind of behavior that having the 2-hour queues helped enforce, because those people who did not invest, since we had fair share, they would flood the queues with those 2-hour checkpointed jobs. Because after a while they had a fair share valued at 0. So if anybody sneezed on the cluster, those folks had to wait for a couple hours.
That's where I just plugged that question I asked earlier, complementing the fair share. The group jobs accrue and max jobs accrue is a nice one, because all you're doing is setting how many jobs a user or a group can have in the queue at a time that are accruing idle wall time priority benefit. Right? It doesn't limit the number they can have in the queue. They can still put lots in the queue, But if you're leveraging the idle wall time, weight on priority calculations, it helps not let somebody dump too much and then get ahead because all their jobs are accruing lots of idle time priority.
That's
So I'd
a
like to
great
say something
explanation.
about these things. There's lots of different technologies you can use, and we went down the road of trying to develop all these different strategies to prevent bad behavior. But in the end, we just came up with something simple: was large users must invest, and that high level policy meant that you're using lots of cluster, you have zero investment. That's got to change, and that allowed us to kind of like even suspend individuals that were not using the cluster appropriately because they were not investing. So those kind of high-level policy ones were a way to not have to over-engineer all the corner cases, because grad students can get really crafty on getting around all the limits that you program into your scheduler to prevent large classes of bad behavior or undesired behavior.
Right. And I'll mention it. I'm not proud that I did it, but there was one time when we had a user who was taking up so much time on the GPU cluster that I was actually moving jobs individually to GPUs that weren't utilized in other partitions. So if there's a priority, you can do it. Setting reservations also works.
One more question, Jason. What's your policy on GPU drivers? Do you upgrade regularly or wait until there's a need or demand?
I believe Montesvita might know this better than I do, but we upgrade on a fixed timetable. I don't think it's I shouldn't say timetable. We tend to save upgrades for monthly maintenance time, and those kind of get updated as needed. We try to find a stable version and stick with that.
Yeah, so for the most part, at least that's the process we have adopted. Right around the yearly maintenance, we do think about OS upgrade, which is also the time we allocate for these driver updates. So for example, the CUDA driver is going to be updated to its latest version around the yearly maintenance that our data center goes through. But outside of that, we don't really try to do it every now and then because it's a major update. So we don't try to mess around with that.
I want to give the other people a chance to present what they've done. So can we save the questions till the end and just get through the other presentations? Or should we?
Yeah, that's probably a good idea. I was thinking John was going to introduce the next person or hand it off to the next person.
Yeah, sorry, I'm having a little bit of technical difficulty with my computer right now. But let's all give a virtual clap for Jason.
Thank you.
All right, next we'll turn it over to Lucas.
All right, thank you, John. Thank you, Jason. I mentioned before the call actually started, I was going to show just very quickly some tooling we put together to kind of mitigate some of the problems I was sure Jason was going to bring up, and he did. So thank you for that. So I'll share my screen here and let me know when you guys can see that, or if you can't see it. Hopefully this will work. Can you see my screen?
Not yet.
No.
Not yet. All right. Let me try this again. All right. How about now?
Great success.
Perfect. All right. So somebody asked in the chat about profiling and sharing DCGM metrics with users. So that's where I'll start. We actually put together what we call internally the cluster portals or the user portals, where you have access as a user to a whole bunch of useful metrics about your behavior in the clusters, whether that be where your priority score stands at, or in terms of your jobs, how well or how badly they're consuming resources. So that's actually where I'll go to the job stats and show you what it looks like from a user perspective, looking at my own jobs. So first and foremost, I have this little overview showing lately what kind of citizen have I been in a cluster in terms of my use of CPU cores, memory, use of the file system, you name it, it's all there. But the most interesting thing is down here, we have a list of individual jobs that I have submitted recently. If we just pick this last one, which turns out to be an interactive job, I have a kind of fine-grained, detailed view on how well or how badly my job was consuming resources. So this particular job, I reserved a whole node in one of our clusters. So that's 48 CPU cores and 4 GPUs, 256 gigs of memory, I believe. And so you can now look at my usage of CPU cores here, not that stellar, that was pretty bad. Memory as well is underusing severely what I asked for. But if you go down, we have some information about what I was actually doing here in terms of processes that were spawned and threads that were running, my usage of the file system. But going to the DCGM question, here's where we actually put that in front of the users and help them reason about, is this even a GPU bound job? Should this thing be running on a GPU? And if so, if I try to use multiple GPUs, how does that affect usage? Is it worth in terms of bang for the buck? If I just throw more GPUs at the problem, time is going to probably go down. But if it does, in terms of usage, am I usually wasting resources or not? So this is what we're shooting for when we put those kinds of metrics in front of the users. So you can see a time series here of usage, all of those collected via DCGM. So streaming multiprocessor activity, actual occupancy, and then in terms of each one of the data types, so the tensor cores, are they being used, how much, for how long, and you get a breakdown here per actual type of core in the GPU. Same for memory, you can check your memory usage here, your memory bandwidth, how often you're going, fetching stuff from memory. So while this is not a profiler per se, it can start, having the users reason about the nature of their code. For example, if we see breaks in usage here, little valleys, little cracks, then we can start thinking about what is causing those. Why is the GPU not always busy? Not at, usage is not always at 100% or is not stable. You can start asking yourself, what might be going on? Am I going to, memory too often? Going to bring stuff back from memory, take some time, GPU is idle, waiting for stuff to do, or am I loading it from disk? So should I, skip using a bounce buffer or something like that? So we put this in front of the users, trying to empower them to kind of ask those questions about their own jobs. So there's more information here in terms of, the power actually used by the GPUs. If you're using multiple GPUs and they're connected, then what does that look like? And in terms of, just the cluster network, there's all sorts of user information we put in front of users here. So the GPU part is coming from DCGM and the rest is coming from the Slurm job database. There's a bunch of job metric exporters behind this, and we're collecting them all in Prometheus, and then just putting this in front of the users in a nice web portal. So if you're interested, if you like what you see here, this is actually work done by one of our colleagues out of Université Laval in Quebec. It's called Trailblazing Turtle. So check it out on GitHub. It's all in here, how it works, the different exporters we have, how we aggregate data, how the website kind of plugs into this whole thing. So that is one of the services or tools, if you will, that we have providing users to kind of help mitigate some of those problems we have, especially, but not exclusively from the AI crowd, but especially from them. The second service or tool that we started providing that is very popular with the AI crowd is Jupyter Hub. So we provide now kind of centralized Jupyter Hub offering in each one of our clusters that we manage. So you go on this website, sign in, and you're going to get asked how much resources you need. There's a time limit here. I believe the time limit in this particular cluster is 6 hours. Oh no, you can go above that, 8 hours. So this will spawn an actual job, an interactive job in our interactive job partition, and it will connect. I'm gonna tunnel to the job on the cluster. You can select whether or not you're going to use a GPU, a certain number of cores. There's a limit in terms of how many cores and how much memory you can ask for here. But once you click on start, this is going to spawn a job. Eventually, I'm going to get connected to the job. I'll come back to this window here in a few minutes to show you what this looks like, because there's lots of interesting things to be said about this. While we wait for my job to start, I wanted to show you something else we're doing that is not actually a service, but in terms of educating the AI crowd about resource usage and some of the kind of malpractices that are really ingrained in this community. So we created workshops and training courses targeting GPU users, whether they're complete neophytes or not. We start from the beginning, so asking what is a GPU even, and when should I use one? So we go pretty deep into the weeds, showing them what is a GPU and when you should actually use one. We have lots of different examples here, some targeted at a general public, and the very last one actually targeted at the AI crowd. So it's a PyTorch example, where we show them things like using a bounce buffer, so reading data from disk, loading it in host memory, then moving that stuff to the GPU's RAM. It's terribly inefficient, but that is usually when you check out some code from GitHub, that is what they're doing, just using a PyTorch data loader. If you're familiar with how PyTorch code is usually written. And people usually just take that at face value, just run that code, don't ask themselves any questions. We try to kind of make people aware of this, more sensible to issues of how the batch size when you're training a neural network affects your resource usage. Should you use a smaller GPU if you're not really using all the juice that an A100, for example, has to provide? Maybe you should use a P100 or a V100. In terms of educating them all around, we tell them about how the bounce buffer actually works and how why it's so inefficient, why they should avoid doing this kind of thing. So in terms of training and workshops, we try to make them more sensible and aware of how a GPU actually works and what are some things that you can do to maximize your usage and minimize wasting resources. We also have a centralized wiki page where we concentrate all of our documentation, AI stuff and non-AI stuff. It's all in a wiki site, but this is a pretty popular wiki page that we have, so PyTorch, where we have a section here that's just about high performance. So how do you extract the most out of our resources using this software in particular? We have an equivalent one for JAX and another one for TensorFlow. The content is basically the same. So if you're using a single GPU, what are the best practices? If you're using multiple GPUs, well, what kind of job are you running on multiple GPUs? And what are the best practices for each one of those types of jobs? So we try to really point the users towards how those things work on our infrastructures. So don't go reading the documentation for DeepSpeed, for example, the centralized one, the official one. Have a look at ours first, how this thing works on our clusters, specifically on our infrastructure. And there are pointers, of course, to the official documentation where it's pertinent to do so. But we really try to show them how this thing runs in this particular cluster. So there's that. And if I may go back to Jupyter here. So once my job starts running, you get an environment like this one, where you can start Python notebooks, R notebooks, Julia notebooks, whatever it is that you're trying to run interactively in a Jupyter notebook. But what I really wanted to show here is this here. So another option for profiling, this is a plugin that, much like what you saw just now in that website, Trailblazing Turtle, provides metrics in real time, so the users can run a notebook here in one tab, and in a tab right beside it, they can monitor their GPU utilization, their CPU, memory, file system utilization, and they can toggle between those tabs and keep an eye as the code runs here in a Jupyter notebook. You can see what is actually going on in terms of utilization. So something pretty interesting. And we had a colleague of ours attend GTC just this weekend, and it looks like folks at NVIDIA provide an extra plugin here in Jupyter Hub that pops up a TensorBoard tab. So in terms of profiling, if you're familiar with how TensorBoard works, it's a pretty complete profiling option. It shows everything there is to know about your PyTorch code, your JAX code, your TensorFlow code out of the box. So this is something we're probably going to look into integrating this plugin into our Jupyter Hub offering. So not only you can see utilization in real time, you can actually profile your code and find out where the bottlenecks are using a more complete profiler than just looking at the CGM metrics. So that is it for me. This is what I had to share with you today. Any questions, comments, reactions?
Lucas, I do have to say that all of the documentation out of Compute Canada or Alliance Canada now is so valuable. We use it all the time. We don't necessarily point our users to it, but we will go there and learn ourselves. So thank you for all the work that you guys do across all the different platforms and subjects. It's just so useful.
Thank you. Great to hear that. So yeah, we do this pretty much as much as we can, kind of put whatever software we're talking about in here, make the documentation really reflect what's going on our clusters. So some of it generalizes beyond our clusters, but a lot of it is really geared towards, using our infrastructures. So.
Any questions for Lucas?
I'll stop sharing here. So the last thing I'll say before we pass the ball to Rob, the education piece, so that workshop I was showing you just now, we've had some pretty good feedback and some observable effects coming out of that particular workshop. So by showing people the very basics of what is a GPU and you should use one, how it actually works, we've had users who were, repeat offenders, if you will, in terms of just wasting resources very, very often, drop out completely from that list of offenders. So they learned the lesson, they know how GPU works now, they're making better choices. So there's something to be said about good old education.
Thank you so much, Lucas. All right, next we'll pass it off to Rob.
Hi, folks. Hopefully you can hear me. I'm going to share my screen here. Hopefully. One sec here. My computer is not.
It's always unfortunate when the demo gods strike.
How's that looking?
This is looking great.
Great. So yeah, just wanted to start with just a little introduction about Vector. We're a young organization. We're only started in 2017. I've actually only been there for a couple of years myself. That building in front of you, if you can see it, only 1/4 of it is complete at the moment. This is the downtown Toronto, what we're hoping to grow into at some point in the future when the university builds out the rest of the block. Our HPC that we run is an on-prem system, much like yours. We have about 800 end users. I have a team of 4 sysadmins to run it. And it's about 200 compute nodes, with 950 GPUs. So it's smallish kind of compute cluster. This compute cluster was purpose built for AI. That was its sort of thing. It wasn't like a compute cluster for other things. And AI sort of came along for the ride as time moved on. So there were some assumptions about how best to run things, and some new ideas that were deviated from the norm, I think, of what you see in a traditional HPC. So I sort of inherited this when I got there and thought, oh, this is interesting. And we do all kinds of different workloads in regards to AI. We do pure research. We're very closely aligned to the University of Toronto, so a lot of postdocs and researchers from there. But we also do industry workshops. So we have people come in and for a few days and learn how to use AI tools. So a portion of the cluster needs for that kind of workload. We have an AI engineering group as well. So it's somewhat varied. So when I got there, the number one complaint from users was about job interruptions. And I thought this was kind of curious, coming from, I worked in health before, where I did supporting a lot of genomics and things like that. So it was a little different. And what was going on was people were having their jobs preempted all the time. And I thought, wow, this is interesting, preemption. Why is it happening so much? So users complain about these checkpointing going on, their jobs are being interrupted. Less science is happening because of this. They're spending more time having to deal with their jobs than actually working on science. So what had happened was Vector had an interesting approach to supporting time on the cluster. They had written a patch actually to Slurm, which is in mainline now, which allows jobs to preempt each other within the QoS. Those of you familiar with preemption within Slurm, it's generally based on a hierarchical structure of QoSs. You have a normal QoS, you have a high QoS, and you can say jobs that go to the high can preempt jobs that are running in the normal. Well, we didn't have that. It was all jobs in normal could preempt each other. They also had no time limits on the jobs. So the idea being that you could get much better throughput that way. But the problem that was happening is that jobs were overrunning each other. They just kept killing each other, basically, over periods of time. So we went on a mission to try and make things better for people. And so we used a number of ways to get there. Of course, we pulled out metrics from our accounting. We looked at job behaviors. We looked at job submissions. What were people asking for versus what they used? Things like that. And we also did some user engagement. We talked to them. We did surveys. We did, we analyzed user feedback. We've actually read tickets from the help desk ticketing system to see what people are saying, things like that. And what I discovered was, it's interesting, the vast majority of jobs on our compute cluster use one GPU, and they last generally under an hour. The vast majority of jobs, which is quite interesting, because I was getting a lot of higher level feedback, in other words, PIs, and at that layer saying LLMs are going to use hundreds of GPUs for days at a time. And that isn't what was happening, what was going on here. So I ended up bucketizing these jobs and saying, okay, there's jobs that run for 1 hour, 1 GPU, 4 hours, 4 GPUs, whatever it is. And I believe it's due to our audience, our user base. Our user base tend to be students for the most part, and they're doing development work. They are using Jupyter Hub sometimes, but VS Code, very interactive style computing. It's not batchy and running for days on end. Those things happen, but it's definitely not as often. So this made natural buckets for me to sort of redesign the scheduler around. One other interesting thing, and I think Jason brought this up earlier, was the naming of partitions. Our cluster is named, partitions are named after a particular GPU model. That's how it was, or how it is. And our users call for a particular GPU model by calling the partition. And it sounds logical to do it that way. And it is logical from a systems management viewpoint initially, but what I'm finding is that it's limiting us in terms of scaling the environment to other needs. I may want to create a partition that has multiple GPU types, for example, for a given department or something like that, like our AI engineering department or something, or maybe some special project or something. You know, so I wanted to curb that sort of behavior with the users and get them to specify models based on the GRAS or GREES specification instead. So that's more, it's a less technical thing, more a people management thing, but it was something that we decided to go for. This is essentially what we did. Now this chart in front of you is kind of what we did initially, but the numbers are not really the same anymore. We've changed since then. But what we did was we got rid of this idea of within preemption. We said that's it. It's not going to happen anymore. And then we created these buckets that I talked about. We created QoSs based on the buckets. Okay. So the majority of our jobs fit into the normal QoS, as you can see. And what you get here is you get more of a, what I call a karma-based system. So the unit of currency in our environment is the GPU. So the more GPUs you ask for, the less runtime you get, essentially, is how it goes. In all the normal cases, okay? And there's always special cases. So we kind of did it this way, is how we did it. And there's no preemption among these things, among these QoSs. So it's very simple. Now, the auto routing thing that I've listed in the right farmost column has to do with our job submit Lua script, which we didn't have one before at all. Users were just sending jobs to the scheduler and there was no interpretation. So I wrote one based on this. If you ask for X number of GPUs and or wall clock time, we shunt you to the right QoS. So we try to abstract it away from the users a little bit so they don't need to quite know exactly how the cluster is kind of pieced together. I kind of like the idea of them describing what they want rather than saying, this is what you have, I'm going to use it. I think it makes for a more scalable in terms of configuration environment. I can change things as things move on. You know, the 16-hour limit for normal is an interesting one. We didn't choose 8 hours for that. Would be a normal working day, people would say, but we did 16 because these students are in our offices for days on end doing work. So we figured it's a longer work day for a typical student, I guess. You know, now we still have some preemptions going on with the high QoS and the deadline QoS. The deadline, they're both by request. You have to request it for a time period. that your jobs can be on those QoSs. And the deadline, that's when there are deadlines for given conferences throughout the year. There's a handful of them that we recognize as and conferences that are sanctioned that you can get priority on these for that. Yeah, and then communicating all of this to users. We didn't just do it. I shopped around this idea. I got a list of top users, power users in my cluster, their PIs and researchers to get buy-in. They actually gave us some feedback that tweaked this a little bit, which was really great. And we moved forward with it. And the reception wasn't too bad. The results are, this is the number of preemptions that were going on until we made the change. You can see a drastic change in this little chart since then. And there was little complaint from users, really. I mean, a couple of people, would complain like they always do when things change in an environment that they're used to. But an interesting thing is that we do continue to improve the environment. I know we're running out of time here. I'm rushing. We continue to try to improve the environment. And one interesting thing that came back from users was, well, they kind of liked the old behavior. Is there some way we could, fit this? And we thought about it, and we came up with a new QoS. We base everything on QoSs. We call it Scavenger. And what that QoS is it allows the user to ask for any number of GPUs with a ridiculous wall clock time of 4 or 5 days. In our environment, that's ridiculous. However, it can be preempted. Your job there can be preempted by any of the other QoSs you just saw. So you get that behavior if you want it. You can go nuts, and but just know that you're going to possibly get preempted more often than the standard QoSs. And it kind of works out. Some people are okay working like that. Others, they want more guaranteed time, so they go to the standard QoSs. It seems to work fine. So we continue to analyze and reanalyze this methodology and check in with users. We do surveys, the whole thing. And it seems to have worked out pretty good. So basically, lessons learned, metrics gathering and user feedback is essential. I'm going to have to go and have a serious look at that trailblazing turtle software. That looks phenomenal. We don't do things to that level, and just some other things outside of this lesson that we're seeing at a higher level, because we're looking at upgrading our cluster. We want to get new GPU technology, and we have another huge project that we want to deliver in the next year as well, which is a whole new cluster. There's challenges in the GPU industry with supply chain and what is pretty much a monopoly, based on NVIDIA's manufacture. There's a real problem there. Just something to voice. That's why Vector, tries to entertain alternative technologies. There's a few small Canadian companies that have come to us and said, hey, we've got this FPGA thing that can run Tensor Core really cool. Can you try it out? We kind of entertain those scenarios a little bit as part of our purview. But the last thing I wanted to get onto was Slurm wishes. And I think I guess I'm looking for maybe answers or input to this as well. It would be really great if users could ask for, in their job submissions in Slurm, if Slurm overall had a little bit better integration with GPU management. Not just ask for GPU model or what you put in your configuration, but capabilities similar to what you can with a CPU, right? Like, it would be great if I need a GPU with 12 gigs of VRAM, and it would just find one for them instead of or some kind of capability. I'm not aware that users can do that. They have to name generic resources by the names that you put in your configuration, typically the model of the GPU or some subset that you create. Also, the DCGM metrics. It would be great if Slurm could pull those metrics itself and put it in the accounting logs and things like that, so we wouldn't have to build all these additional tools and try to marry them in. I think it's difficult. Again, the trailblazing turtle would be interesting to look at, see how it's done there. And the last sort of data point would be the MiG instances. I don't know if anyone's using MiG in production right now. We are not. We only have a small number of A100s. But it would be cool if Slurm could auto MiG devices. I don't think it can do that right now. So a user wants, again, 10 gigs of VRAM. It would be really cool if the scheduler could say, oh yeah, I could fit that on a card over there. That's, and create it and do it live, rather than us sysadmins trying to create things statically for a long period of time. I think MiG is probably going to be, it's going to do to GPU computing what virtualization has done to standard computing in the data center. I think it's probably going to take off at some point. Anyway, we're totally out of time. I'll stop my share if that's okay.
Thank you so much, Rob. I think we might have time for a question or two before we go ahead and sign off. Feel free to unmute and ask Rob any questions.
Yeah, Rob, there are a bunch of comments in the chat about how people are currently doing this. Some are using like Slurm tags. Some are using weights. All of this will be in our notes as well. So if you have to leave or you didn't catch any of this, that'll all be there. Does anyone have any questions for Rob?
I think everyone's blown away by all the information.
There is one question a little bit back in the chat. Do you anticipate usage of the scavenger QoS to drop substantially over time?
No, the trends are showing that it's pretty even, Steven. There's a handful of users who tend to gravitate toward it, but I don't foresee it changing.
Hi, this
We've
is Dan.
noticed.
Oh,
I'm sorry. Go ahead, Dan. Go ahead.
They're from University of Pennsylvania. We've used a partition, a standby partition, kind of like your scavenger. And what we've experienced is people abusing that to the point where the scheduler seems to be starved, not the resources, but the scheduler. It causes problems and people complain, hey, this person is submitting, 5,000 standby jobs, and that's causing problems with me trying to get my jobs in. Have you experienced any of that yet for your scavenger?
No, I haven't yet. We don't really have a limit on the number of jobs people can submit. But I don't think my user base is large enough for me to have that as a problem at this point.
We have a tiny user base, and apparently they're causing the problem already.
Oh, really?
Thanks.
Oh, interesting.
Yeah.
We had that problem years ago, and we did end up instituting limits. So at most, a user can submit 1,000 jobs at once, including for our scavenger partition, and that seems to have helped.
That's what we ended up doing as well. And then, of course, you have that one user who says, but I have 5,000 real jobs. But okay, thanks.
Right.
Well, if there are no more questions, let's once again thank Rob with a virtual hand clap, as well as Lucas, who I forgot to extend the offer to as well. And then also thank you, Jason, for getting together this great panel. I hope to see everyone again for our next CaRC Systems Facing meeting. And please join the CaRC Systems Facing Slack and continue the conversation. Thank you all, and hope to see you next time.